carry on. There we are. Look at that problem. Look at the problem. Thank you. 7.2. 7.2, this one. In the diagram alongside, O is the center of the circle ABDC. O is the center of the circle ABDC. What does that mean? It means point A, point B, point D, point C lie on the circumference of the circle. Then we say they are concyclic. They lie on the circumference of the circle, meaning that they are concyclic. O is joined to B and C. O is the center. Now you join O to B and O to C. Therefore, you've got OB as the radius, OC as the radius. And you know the radii of the same circle are equal in length. Angle OBX. Check OBX. It's clearly marked on the diagram. OBX. OBC, I'm sorry. Angle OBC is equals to X. Angle OBC is equals to the X. Sorry for that. The first question, determine with reasons the following angles in terms of X. The first one, you determine O1 in terms of X. Second one, determine angle A in terms of X. Last one, 7.2.3, you determine angle D in terms of X. 2, 4, 6 marks. I think this 6 marks, you can finish it off in 4 minutes time. I'm going to give you 4 minutes to try this one on your own. Remember the key, indicate the given information in the diagram, and then you apply your theorems. Good luck. I'll continue with the solution to this problem after 4 minutes. Carry on now. Welcome, welcome. Check your work against mine. Check your work against mine. Thank you. In the diagram alongside, O is the center of the circle ABDC. O is joined to B and C. O is joined to B and C. What does that mean? It means OB is equals to OC because those are the radii of the same circle. Angle OBC is equals to X. It's marked X. This angle here is marked X. So the first question, determine with reasons the following angles in terms of X. Let's start with O1. Here is O1. 7.2.1. Statement number 1. Angle C1 is also equals to X. Why do I say angle C1 is equals to this X? Why do I say this angle C1 is equals to X? The reason is that OB is equals to OC, and those are the radii of the same circle. What does that mean? It means this angle here is also X. So it becomes easy for us to determine O1 in terms of X, because this angle, O1, plus X, plus C1, they all give us 180 degrees. Those are the angles of a triangle. We know angles of a triangle add up to 180 degrees. Interior angles of a triangle. Angles of a triangle. Interior angles of a triangle, they add up to 180. Therefore, we've got O1 plus X. Remember, C1 is also equals to X is equals to 180 degrees. Then you make O1. We make O1 the subject of the formula. Angle O1 will then be equals to 180 degrees minus X plus X gives 2X, and then transpose to the right, then it goes minus 2X. then that will be the size of angle O1. 7.2.1, O1 will then be equal to 180 degrees minus 2x, because the question states determine with reasons the following angles in terms of x. So O1 in terms of x will then be equals to 180 degrees minus 2x. I hope you enjoyed that one. Second one, let's determine angle A in terms of x. Numbering is key. 7.2.2. We want to determine angle A in terms of x. Remember, from the given statement, O is the center of the circle. So if O is the center of the circle, we then say O1 is equal to twice angle A. Remember, there is a theorem that states the angle which an arc of a circle subtends at center is twice the angle it subtends on the circumference of the circle. So you write down the reason. Angle at center is equal to 2 times angle at the circumference of the circle. Angle at center is equal to twice angle at the circumference of the circle. Check O1. Remember, angle O1, we have from 7.2.1, O1 is equal to 180 degrees minus 2x. Now we substitute it here. We substitute O1 by 180 degrees minus 2x, which will then give you 2 times angle A. So to determine angle A, you divide by 2 both sides. Let's divide by 2. If you divide by 2 here, you've got angle A here. You divide by 2 here, it's 90 degrees. You divide by 2 there, it's x. Now we're done. We've got the value of angle A in terms of x. Therefore, in terms of x, angle A is equal to 90 degrees minus x. That was 7.2.2. I hope you also got it right. Thank you. Let's check the last one. 7.2.3. 7.2.3, angle D. Determine with reasons the size of angle D in terms of x. Where is angle D? Here it is. Thank you. Let's answer 7.2.3 and see how it goes. 7.2.3. If you look at the diagram, check angle A, check angle D. How do they relate? Because A, B, D, C are points on the circumference of the circle. Therefore, it means A, B, D, C is a cyclic quad. As a result, angle A plus angle D must give you 180 degrees. Those are the opposite angles of a cyclic quad. There is a theorem relating to cyclic quad which states opposite angles of a cyclic quad are supplementary. That's why we say angle A plus angle D is equal to 180 degrees. Those are the opposite angles of a cyclic quad. We said angle A plus angle D gives us 180 degrees. These are the opposite angles of cyclic quad. Those are the opposite angles of cyclic quad. Opposite angle of cyclic quadrilateral. Angle A from 7.2.2, angle A is equal to 90 degrees minus x. So we substitute angle A here by 90 degrees minus x plus angle D. They will give us 180 degrees. Now it's easy for us to determine the magnitude or the size of angle D. Transpose 90 to the right. 180 degrees minus 90 will give you 90 degrees. This is x. You transpose it to the right. It becomes positive x. Therefore, it means angle D will then be equal to 90 degrees plus x. I hope you enjoyed this one. I hope you got it right. Remember, the objectives for today's lesson is to revise Euclidean geometry. All those riders, come up with solution to the riders, because we believe practice makes perfect. If you do lots and lots of exercises relating to the solution of solving geometric riders, then even in the exam, they will become easy. Thank you very much. I think we should do one more exercise before we go for a break.